Hi, everybody. My name is Jessica White, and I am Managing Editor at Supply Chain Brain. I want to welcome you to today's webinar presentation on AI-driven best practices in the warehouse, presented by Lucas Systems. Before I introduce our speaker, let me tell you a little bit about Lucas Systems. The company was founded in 1998 as an innovative voice-directed solution provider. They were actually first to deliver voice solutions on open platforms and multimodal devices, and also first to deliver voice apps on Android devices, including smartphones and smartwatches. Over the past 5 years, Lucas's focus has been on software solutions for on-the-floor process optimization. With that, I want to introduce Dan Keller. He is Senior Solution Consultant at Lucas. Dan has over 35 years of experience helping businesses implement distribution technologies for retail, healthcare, industrial manufacturing, and much more. Dan, thank you so much for joining me today, and I will go ahead and turn it over to you.
Thank you so much, Jess, and welcome everybody. In today's webinar, we'll introduce you to some ideas on how to use technology to elevate associate job satisfaction and to optimize your on-the-floor processes. So, the big problem everybody's facing: not enough qualified warehouse workers to maintain adequate service levels. You know, everybody is facing the same problem. Can't hire enough people. So let's think about or talk about some solutions to that. Well, here are four, no, not really, three ideas, okay? Increase worker retention by making the job easier to do and easier to learn. Optimize your processes to get better throughput with your existing workload and your existing workforce, and then add automation to reduce your labor requirements further. That is the subject of today's webinar. Interestingly enough, recently, Lucas surveyed with Wakefield Research 500 warehouse workers across the United States. Here's Don to tell us a little bit about what we learned.
There's been a lot of talk about attracting and retaining warehouse workers, but not so much from the perspective of the on-floor warehouse workers themselves. As a pioneer in warehouse technology and solutions that help warehouse workers do their job better, Lucas has developed the Voice of the Warehouse Worker Insights. We surveyed 500 on-floor warehouse workers across the U.S. with the goal of directly capturing the warehouse worker's voice and delivering actionable insights to warehouse and DC leadership. Here's a glimpse of what they had to say. Labor shortages have been an issue for a very long time. However, what we found is the majority of warehouse workers want to keep their job and do it very well. However, 3/4 of the workers surveyed said they are likely to take a slight pay cut at another company that has more technology for them to work with. But workers want relief from the physical and mental strains of working in the warehouse. This might not be shocking, but what is a surprise is how on-floor workers see technology as a critical solution and highly value the impact technology has on transforming their work experience. But what kind of tech do workers say they want? They want tech that will help them be more productive and accurate. That includes robotics, with 75% of workers being excited by the idea of working with robots, if it's done right. Find out more about how the warehouse worker feels, what they believe, what they fear, and what they hope for. Get deeper insights on managing your workforce with Lucas Systems, Voice of the Warehouse Worker. Visit lucasware.com/Voice of the Warehouse Worker to download the Voice of the Warehouse Worker Insights.
Interesting. So what are we going to do? We're going to try to make the job easier to do and learn with voice so that those people are happier and stay longer. Voice-directed applications, which incorporate complementary technologies like barcode scanning, visual cues on screen, and connected like lights, have proven to be the most effective method to train and retain hourly employees. Unlike lights, the same technology and methodology can be applied across multiple DC processes, not just picking, but also order consolidation, sorting, inbound handling like receiving and put away, pick bin replenishment, cycle counting, and truck loading. Some examples of applying intelligent voice-based applications to warehouse processes. When you can make a warehouse associate's job easier to quote unquote get it right, they have higher job satisfaction and tend to stay longer. This is a good example of this exact idea. So this is about the Sportsman's Guide, an e-tailer in St. Paul, Minnesota. Here's their story.
Sportsman's Guide is an e-retailer, so we service all the hunter and fishermen in the United States, camping, anything for the outdoors. My name is Jason Klum. I oversee warehouse operations at the Sportsman's Guide. Yeah, the Sportsman's Guide has been around for over 40 years, so we started off as a catalog company where we were sending literally millions of catalogs out on a weekly basis. You know, years ago, we made the shift over to be more of an online e-tailer. So our catalog business has dropped down significantly, but most majority of our business, it's in the high 80%, is coming via the web now. So we've seen a nice business growth. Obviously, a lot of online e-tailers seen a significant boost in business, and we can see that business continuing to grow over the next few years.
My name is Jerry Marcotte. I am the outbound supervisor in charge of picking, packing, and shipping. So this warehouse is roughly 330,000 square feet of racking space.
347.
Pick 1.
Grab 1.
9 Alpha. Put 1.
354. Put 1.
We have typically around 30,000 plus SKUs.
At HQ, we're doing on average about 8,000 orders a day. There's about 1.5 pieces per order. So we're up over that 12,000 pieces a day. And that's during this time of the year. Coming into peak season, we're gonna about 2.5 times that volume out of this facility. The biggest vision for the Sportsman's Guide is we wanna be fast to the customer, and then we wanna be accurate, right? You know, so if you walk around the DC here, you're gonna see a lot of signage that says, "A satisfied customer with every package," and that's our motto. So Jennifer helped us meet these expectations by increasing our productivity. So when we launched with Jennifer, we've seen an 18% in productivity gain. And then also we've seen a nice increase in our accuracy.
Jennifer does everything for us but reach out and grab the product. She sends us to the locations, tells us where to grab from, how many to grab, where to put it on our cart. She won't let you make a mistake. If you're at the wrong location, she will tell you invalid.
I love work with Jennifer because it's more easy, because she told me everything I had to do every day.
So much nicer because you don't have to mess around with anything. She tells you where to go, what to do, and it's much simpler.
199.
199. Invalid. 6. 98. 11.
198. Grab 3.
Pick 3. Put 7 Alpha.
When you're bringing in seasonal associates, it's just that training that needs to occur, right? So with the increase in productivity, we've seen a decrease in our training labor, which has helped significantly.
It should only take a few hours. Some people take a whole day. Some people need extra help. It just depends on the person. Some people will learn in 2 hours and get it going right away.
Where we've seen a nicer jump in accuracy was actually from the seasonal staff. So the seasonal staff was running about 98%, 98.9% accuracy. And then once we got them trained on the Lucas system, that went up to about 99.5.
I cannot imagine going back to the old way we used to do things, picking by visual paper.
We built our application together around our process. And that's one of the reasons why we went with Lucas.
It's better with Jennifer.
Okay. I think that's a good story because in essence, again, very important to them with a lot of seasonality to get those seasonal workers up and running quickly. So we've learned from our past few minutes that there is good ways to utilize some technology like what Lucas has to make it easier to make the tasks easier to learn and do. The next step is to use AI and smart software to optimize the process. Okay. The first place to look for this is in smart batching and in smart pick paths. This opportunity to move from one trip to one task per trip to batching is very important. Now, I would hope that most of you who are doing small orders or many, single line orders are already batching your work in some manner. So picking multiple orders in one trip to the warehouse. In a direct to consumer process, you absolutely have to do that because, the travel will just kill you otherwise. You may be using a pick cart that looks like this. This is an example of one of my customers who's got, I think they do like 32 orders at a time. And again, small, fill it in there and then bring it to the backing stations. But not just batching, but smart batching is what makes the difference. So Lucas uses AI-based something called dynamic work optimization, which combines smart batching with pick path reduction to provide game-changing productivity gains. The smart batching software also takes into account order priority, so you can achieve the right balance between pick density, yielding the highest productivity, with making sure that you will still make your gate times for orders which may have come in late, but absolutely must be shipped today. Smart batching has been shown to cut 20 to 30% of travel time in a process like we've just illustrated. Here's Kyle to tell us a little bit about how dynamic work optimization actually works.
Consider the following warehouse map and visual pick list. The blue dots are individual picks for a single order, all of which need to be picked by our RF user there next to the start. Now we see their pick path as dictated by a WMS-driven pick sequence, in this instance, Serpentine. The user will traverse each aisle that has picks in it, and in most cases, traveling the entire length of the aisle. In this example, they would have traveled about 934 feet. Let's look at the path that is generated using our pick path optimization engine. It uses a number of traveling salesman mathematical algorithms, crunching travel costs across a digital map of the warehouse. Now we see that we have significantly reduced travel time for our user. Instead of picking those picks at the bottom of our map in aisle sequence, we save a ton of walking by grabbing those at the very end. This results in an estimated savings of 18% for this order. All of this extra travel is eliminated. Now many of us have seen really sharp pickers in action, ones that can find workarounds or shortcuts that shorten this distance. But what about your newer pickers or your temporary force that you just brought in? Our engine helps to democratize these shortcuts, in addition to making our fastest pickers even better. Now that we can use math to help us build efficient routes, and now that we know which orders can be picked based on priority, let's look at the third component, intelligent batching. One of the key ways that warehouses can save on travel time is by batching orders. We now see a group of the next available orders in the system overlaid on our map. So we first see the pick path generated by our engine to pick order number 1, the highest priority in the system, traveling a distance of 432 feet. Most warehouses batch in a first in, first out manner. So the user will be assigned order number 2 to pick with order number 1 in their batch. Picking both together results in a total travel of 704 feet, much shorter than if they had picked them separately. However, there is a better way. Lucas's AI-based tools look at the pick path of all available orders in the system to help determine what an optimal batch is. Looking at the map, which order matches really well with our current pick path? If you noticed, order 6 in green almost matches our pick path perfectly and will make a great addition to our batch. We see only a small amount of additional travel is needed to complete both orders, resulting in 456 feet of travel to pick both orders. Consider how much greater the benefits could be once we pick batches of 4, 8, or even 20 orders.
So, AI-based optimization can make huge differences in terms of the pick path and in terms of smart batching. So now we're going to show you a story from a customer who's actually using this in their e-com area. So as you listen to this case study, focus on what he says specifically about e-com. Here's the Southwire story.
My name is Chuck Jones. I'm Director of Distribution Modernization for Southwire Company.
Southwire is one of North America's largest manufacturers of wire and cable. We also sell tools and assembled products.
We have a 30-plus plant network where we produce wire and cable, and we also have a 10 distribution center network where we distribute those products as well. We have a retail customer base. We also sell through the energy sector to help modernize our distribution network. The first area that we look to from a modernization standpoint has been our investment with Lucas Systems. We've invested and implemented the system at 4 different sites. We've seen some pretty good benefits as a result of the system.
Before we were using Lucas, very manual. When we transitioned to Lucas, it sped our picking up tremendously. Day-to-day picking on SAP would be, picker would have a scanner and a tablet. They'd have to read the tablet to know what location to go to and have to scan the product, read the tablet again to see how much material they're supposed to pick for what order. Current operation with Lucas, we have a handheld device with a headset. You don't even have to look at your handheld device. You don't have to read anything. Put your headset on, keep your handheld device close. Jennifer tells you everything you need to know.
Lucas makes it to where we can fix things as we're going, and it's easier to pick and understand how many parts and how many eaches. She explains it very well. 5428.
Pick 8.
It was a very smooth transition. One thing that Lucas did help with is training. Training time for picking reduced tremendously.
Originally, we didn't have any logic that was backing how those batches are built. It was literally just picking the highest priority deliveries and putting those in a batch together. But Lucas has given us the capability to really optimize how those batches are built. The advanced technology basically takes all the assignments within a certain date range and minimizes the travel time for a particular picker based on the batch of work that's assigned. So it essentially is going to overlap like SKUs to that location. Ideally, you don't have to go there once for multiple orders versus different trips. So
Lucas plans our pick path for us, so it probably saves me 2.5 hours a day.
I think the Lucas AI was pretty important. It's definitely optimizes how work is done. That was a big driver in the cost justification of being able to invest in a system like this. Safety's been a huge benefit as well, just having the users be kind of hands-free, eyes-free now that when they're driving their lifts around previously, they're having to stare at a tablet to get the relevant information to know where to travel and what to pick. The biggest driver for all these projects really has to do with productivity. There was a lot of skepticism about changing our picking system again, but over the course of a couple of weeks, they eventually adapted to it and accepted it pretty well. From a supervisor and lead standpoint, they loved it from the beginning.
First time using the supervisor dashboard, it was easy to pick up. Pre-Lucas is very manual. You had to pull reports. Most of my reports have went away since Lucas.
The Lucas Management Console helps me, manage productivity by, priority orders, what needs to go out. We have a variety of orders that are hot throughout the day, so just managing priority, making sure that they're all available to pick in Lucas.
We knew going into the project that we'd see productivity gains. That was obviously the hope, but the amount that we saw in our .com picking area has just been outrageous.
So we've made it really easy for associates to learn and do their jobs. And we've applied as much smart software to make the tasks as efficient as we possibly can. So you've heard all about that from these 2 case studies. What's the next step? Okay, so you've heard a lot about robots. The next level is to take the mundane tasks which people may still be doing, like moving pick carts or running pallets, and let machines do these tasks, where you have the opportunity to further reduce travel time for units of work to go from one place to another, you can look at the new breed of AMRs to accomplish these tasks. There are a number of companies now offering various flavors of autonomous mobile robots, almost all positioned to be collaborative with your human workforce. You'll still need optimization software to coordinate the collaboration of the AMRs with your human workforce. Let's hear from Ron, who will illustrate the coordination and orchestration.
In our final example, we're going to apply digital automation to optimize and coordinate the work of humans and robots, orchestration, if you will. This coordination will be handled by our DWO, or Dynamic Work Optimization module. Currently, the robots or AMR company's solution is to have human workers read a robot screen to know where their next action is. But in our example, the pickers will receive their instruction through headset and use voice or scanning or screens to actually confirm the picks. So we're kind of decoupling having to read the screen on the robot from being able to direct and move the pickers or the human labor around. Adding coordination and communication between robots and people will provide significant value in reducing travel and will also result in better positioning of the resources, both robots and humans. Before I start, I will again mention the additional advantages of dynamic work optimization, which is the real-time batching of orders. That feature is not represented in this simulation, but could be added to the overall solution. So here a picker is directed to pick location and robot A. Once the first pick is completed, the system takes into consideration the location of the picker as well as the location of all the picks and the corresponding robots. The system directs the picker to the location directly behind them and coordinates moving the correct robot to that location, and also positions robots for future picks. Once that pick is completed, the system directs the picker and the robot to the next pick location. As you see here, the picker is directed to the pick in the next aisle instead of the robot that they could see in the current aisle, which is the current solution envisioned by the current generation of robotics. If the system detects sufficient demand, or if labor becomes available, a new worker, the little dot at the top of the screen, may be directed into the zone. As picker 1 is completing the pick to robot C to provide a more efficient pick path and distribute work among available pickers, the system has determined that robot B should be repositioned. And the second picker gets directed to robot C. Picker 1 and 2 continue to get instructions and complete their picks. Because they're directed, they don't have to scan into each robot before they pick, which is, again, the current practice. They can confirm placing the items to the correct robot or tote by speaking a check string or scanning or using RFID. And we now watch them complete their picks. As picker 1 completes the pick to robot B, they can be directed to another area of the warehouse, again based on the demand, because now there's not enough pick density to support 2 pickers in this area. In summary, this slide shows the travel path traveled by picker 1 with only robot-assisted picking. The total travel distance here is represented by about 412 feet. This slide shows the path with human-robot coordinated picking, showing travel of a total of 202 feet with an over 50% reduction in human travel. And this slide shows the two pick paths, the kind of the before and after overlaid.
Okay, so to summarize, 3 levels of optimization opportunity to explore. Make the tasks easy to do and easy to learn using voice-directed applications. Optimized units of work using smart batching and smart pick path, AI-based solutions. And then add AMRs along with your optimization and orchestration software to maximize your worker productivity. Hope you learned a lot and enjoyed it, and hope to see you and talk to you soon. Thanks, everybody.